we wanted before we start to have to launch a quick poll, and then so that we leave everyone the opportunity to join in. So you should have a poll showing on your screen in a couple minutes. We just wanted to know what your, check here. Here you are. You should see the screen showing on your end. We wanted to know a bit more what is your role in the project team, so that we can adjust a bit more the presentation today. So we leave that so a couple more minutes. Whether you're an owner on a project, an engineer, an architect, a contractor, a student, or whether you don't feel like you're part of any of these topics. Sustainability is obviously a topic that you can read on different aspects. So that's why it will help us to adjust a bit our talk. So before I forget, and while everybody is filling in this poll, some housekeeping topics before I forget. So this meeting is recorded, as you may have heard, and the recording will be shared to you in a couple of days. Same for the certificate that will be sent also by email to you from our team. You can ask questions during the presentation at any time. Do not hesitate. That will be with a Q&A button that's at the top or the bottom of your screen. And then we'll take 15 minutes at the end to go through your questions. If we don't have time to answer all your questions, then we will come back to you later on by email. All right, so just to end the poll and see what we are at. So we are mostly engineers around the table and consultants. You should see the result right now. Some owners and contractors, right? So great. Happy to chat with everyone, and hopefully you'll find this webinar fruitful and interesting for you. So my name is Simon Winieski. I work at Menard Canada with the Ontario team as a project manager, and I also lead the environmental ambition for the world country. I am extremely happy to have Gerald Verbeek with us today. So Gerald is working with Ornamics for piling die testing in the US, and he's also the chair of the Sustainable Committee at the Deep Foundation Institute, or also known as DFI. And I think we are, Gerald, we're good to go and then talk more about sustainability together.
Very good, Simon. Thank you very much. And I appreciate the opportunity to talk about sustainability, because obviously that is a topic very near and dear to my heart as chair of the Sustainability Committee. The issue, though, is often problematic, or is still something that plays a role, is that not everybody necessarily agrees about the need for sustainability, the background of sustainability. And what I will try to do in the next 20 minutes or so is to give you some food for thought, to talk about the carbon footprint, as you see illustrated on the right-hand side of this slide, but also to talk about sustainability in general, why it can be done, and also try to emphasize that sustainability in and of itself ties very nicely with other aspects that we are trying to pursue to make things better, cheaper, more efficient. What we're going to do, there we go. As I told you before, Simon told you before, I'm the chair of the Sustainability Committee, and I'm also the chair of the Conference on Foundation Decarbonization and Reuse, an annual conference that's being held, has been held in Holland and will be held again next year in Holland. And as you may hear from my accent, I'm a Dutchman. And you may wonder, well, why do I emphasize that? One of the things that I learned as a Dutchman, coming from a very small country, when you look at the world map, is that what happens around you in other countries does affect you. Climate in the Netherlands is very much affected by the heating in the Gulf of Mexico. The water is coming with the Gulf Stream across the Atlantic Ocean to the North Sea, and that affects what we are experiencing climate-wise in Europe. And therefore, sustainability, climate action, climate interaction is something that has been something that has played a role for me for a long time. But what I'm trying to do today is try to be not very biased, to give you a more objective part of what sustainability is and why we need to address it. What you see here on the screen is a first slide. It gives you an indication that you have different aspects. You have economical aspects, you have a social aspect, and you have an environmental aspect. And those aspects all come together and overlap each other. And to simplify it a little bit, you see that basically here, that you have the environmental protection, you have the social aspects, you have the economic aspects, and where those three aspects intersect, that is where you have sustainability. That is where you have a sustainable development that is going on. Now, sustainable developments or sustainable activity is really a combination of a whole bunch of different elements. And what you see on the screen right now is something that the United Nations developed a number of years ago. It's the so-called Sustainable Development Goals, or the SDGs. And they come up with 17 of those goals. 17 aspects that all play a role in whether something is sustainable or not, and what kind of attention you need to pay to ensure that something is sustainable. And what I really want to focus on is aspect number 13, the climate action. And what you see there is basically an overview on the left-hand side that we have emissions. What we do is creating emissions into the atmosphere, and those emissions are creating or affecting our climate, and therefore we need to do something about it, because these climate actions may cause more hurricanes, more higher temperatures, more forest fires, all kinds of stuff. And that is why the Paris Agreement basically said, okay, we need to do something about those emissions to at least minimize the effects. I realize full well, and that's what I said at the very beginning, that there is no consensus among you as the attendees, but I have to take the world at large, that what we're doing has an effect on climate. Some people may say that, well, the emissions really don't affect climate. The reason that you have climatological changes has nothing to do with what we're doing on Earth as human beings. So there are pros and cons. And I'm not here to try to convince you for one reason or the other. But most of us, as you saw earlier at the results of the polls, are engineers. And what I would like you to do is accept that we may disagree, may accept that we have different opinions, but at the same time, look at some data. And as engineers, we always like correlations. And when we have a good correlation, we start to believe in this whole thing. So let's look at the carbon dioxide levels in air going down about 800,000 years. What you can do with taking ice cores is analyze what the CO2 content in the air has been. And you see that for the longest time, that varied somewhere between 180 and 300 parts per million. So yes, CO2 levels in the atmosphere change rather dramatically. 180 to 300 is about a factor of 2. But what you see also is that in the 1950s, we started getting above the 300. And fairly recently, we even we started to exceed 400 level, and we're now somewhere around 420. If you combine that with the temperature, the average temperature on Earth, which again, you can derive from the ice cores in something that the NASA and some of other scientific agencies have developed over the years, you see what I think is a fantastic correlation between the temperature and the CO2 levels. It's not a perfect correlation, but you start seeing that as the CO2 levels varied between, say, 180 and 300, you start seeing that those temperatures went up and down as well. And now we are in a period where we are in uncharted territories when it comes to CO2 levels. And it only may also indicate that we're in uncharted territories when it comes to the temperatures. Does it affect us? Well, when you look at what happened this year in Canada, we have had a tremendous amount of forest fires. And those forest fires were basically because of the drought conditions that you had throughout Canada, which were a result of the climate action. Here in the United States, we've had tremendous high temperatures in large parts of the country. But we also have seen that the results of the forest fires in Canada, the smoke and the particles in the air that came south of across the border into the United States, affected us here in the United States as well. And it implies again that what you start seeing, that what happens in one country has an effect in another country. And that's where I mentioned at the beginning that I was a Dutchman, because obviously, as I explained to you, the climate in Holland is largely affected by something that happens far, far away. So climate action is something that we at least should, as engineers, should take seriously because of the correlation between the CO2 content and the temperature on Earth. But when we say that and we start looking at this whole thing, you may wonder, okay, yeah, fine, of course, we can, obviously CO2 content affects the temperature of the globe. So yeah, that is fine, but why would we do something like that in our industry? Why is it important that the construction industry is involved in that as well? And what you see there is that about 11% of the CO2 emissions come from building materials and construction. So our industry plays a major role in creating emissions into the atmosphere of CO2 and other greenhouse gases. You can go even one step further, is when you look at three materials, concrete, steel, and aluminum. They're responsible for about 23% of the global emissions. Now, those are materials that we use day in, day out in our industry. Now, foundations are often concrete piles or steel piles. We have rebar. So those materials play a major role in creating the emissions. And that's why it's such an opportunity that we have in our industry, not only because, as I showed you in the previous slide, because we are generating a large percentage of the emissions, but also the materials that we use. And if we start using them less, see an improvement, that we can really affect what's happening. So let's look a little bit about where we are. Here you see the building life cycle. It starts on the bottom left-hand side, where we start creating products that we are then using to build a structure. Then we use that structure, and at the end of its lifetime, we also need to make sure that the structure is then either destroyed, abandoned, taken apart, whatever you want to call it. But you have this end of life stage, and then hopefully be able to recycle quite a few of the products. And quite a few people would say, well, if we didn't recycle what we have used, we're doing pretty well. Well, up to a point that is true, because it would even be better if we avoid building, or if we do build, reduce the amount of what we are constructing, or substitute it by things that are more effective, more efficient, more sustainable. And if we really cannot do anything of that, we can compensate it by taking other actions, for instance, planting trees or doing other environmentally sound issues. I would say, well, for foundations, how can we do that? Well, let me give you a few examples. If we have a building and we reuse the foundation, we basically avoid that we have to build a new foundation. And that's why I told you at the beginning, as chair of the conference on the foundation decarbonization and reuse, that's something that I really want to advocate. But we can also, if we do have to build a foundation, if we use a more elaborate testing program, we can increase the resistance factors and therefore reduce the size of the foundations and then come up with a more sustainable solution. Or what we can do, and that's something we're going to talk about today, instead of putting concrete and steel in the ground, we can do ground improvement and substitute the one material for something that is probably much more sustainable. So there are all kinds of things there that at first sight you might say, well, we cannot do that in our industry, but that we can really apply throughout in what we're doing. And of course, as I already said, the conference on foundation decarbonization and reuse that will take place for the second time next year in Amsterdam. Yeah, I would strongly encourage you to get involved with that or attend that conference. So hopefully by now we've seen that we the emissions that they play a role in getting the temperature of the Earth. We've seen that in our industry, we can do something about those emissions. And then the question comes up with, what is the carbon footprint? And the carbon footprint is really a summation of all the activities that we do and the emissions associated with those activities. The question then is, what is the carbon footprint of our industry? And if you go and look at that, the easy solution is that is a tool that we have developed together with EFFC and DFI, the carbon calculator. And it's a tool that is very simple. It's basically just, it's an open tool. You can use it, you can download it, as I showed you in a few seconds. It's a spreadsheet where you can enter all your data and get an indication of what your emissions are. And we take then those emissions from all activities, from going to the job site with our staff, bringing equipment to the job site, creating the materials that we need there, and then also putting the whole project together. And when you add all those factors together, you just start adding up with all those components, get a total carbon footprint of the project. And here you see the link to the website, and probably you'll see that same link coming in the chat in a few seconds, so that you can download it and have it available in the future. It's a tool that's about 10 years old, and that is being supported by the industry, both on this side of the Atlantic through DFI, and the other side of the Atlantic through the European Federation of Foundation Contractors. It's updated frequently so that we have good emission data in there. And what that carbon calculator allows you to do is to come up with the complete scope of the emissions, scope 1, 2, and 3. Scope 1 is basically the fuel consumption that we have to bring staff to a job site. Scope 2 is the electricity that we're using and other power that we're applying on the site. And then scope 3, by far the largest part, is the emissions caused by generating the materials and putting everything together on the job site. And that's what we need to focus on, because for most in our industry, the scope 3 contributions far outweigh scope 1 and scope 2. But there's something else that we need to look at. What you see here is the results of some analysis that we've done with the carbon calculator. And you see all kinds of different foundations, different foundation types. And we're not saying here that every foundation type has the same carbon emission level, but what we're showing here is the contribution for the different foundation types, where it comes from materials, from waste, or from transport. And you basically see that for most foundation types, the material, the brownish part, is by far the largest part, by far the largest component. So if we know what that material component is, if we can reduce it, we automatically reduce the total emissions. But when you go farther to the right-hand side and you come to ground improvement, you suddenly start seeing that there, since we don't add many materials, the situation changes quite drastically. And therefore, it's important that you understand the impact when you have a type of foundation. If you say you're using a concrete pile, that has a completely different impact than when you have a ground improvement, and that's, after all, the topic of this presentation. But also what I want to emphasize, it's not just the Green Deal that we're talking about. Last year, I moderated a webinar with DFI on sustainability, and I invited 4 executives of American companies, North American companies, to participate and give their views on sustainability. One of those people that were part of the panel was Seth Perlman, the chairman of Menard North America. And he basically indicated that, listen, it's all fine if we're talking about sustainability, but unless it's a financial benefit, we really are not going to get anybody to really step up to this whole thing. At the same time, we need to use techniques and solutions that put less carbon in the atmosphere, as I pointed out earlier. And one of the things that really means is that sustainability really means that you are using less conservative designs, using fewer materials and resources to produce. And what does this mean? Now, what is the next step? Well, that's to try to something new. And I give you one example of a case study that was put together for the DFI magazine not too long ago by Katie Costello from Isherwood. And I'm more than happy to use that example, where you talk about the construction of a station in Toronto. The specification was not specifically defining what had to happen, but they gave a performance-based specification. And the performance-based specification allowed the contractor to optimize the design to come up with a more sustainable solution for that production. Using carbon calculator, we then came up with the emissions or the reduction in emissions, and then to clarify that impact, we use another tool from the Environmental Protection Agency in the United States. It's the greenhouse gas equivalency calculator. And that basically allows you to come up with a very simple equivalent, because when we're talking about tons of CO2 emission reduction or addition, it's very hard to figure out what it really means and what how it equates. Well, with this calculator, you can come up with something like that. And basically, what happened was that in her project, the station in Toronto, we could reduce the emissions by 530 tons of CO2 emissions. And it basically shows you there what the equivalent is. Basically, the energy that is used for 67 homes in 1 year. And with that, we can really show as the industry that we can do something. We can reduce the amount of materials, therefore reduce the carbon emissions, therefore have a positive impact on the temperature on the Earth, but we can also present it into terms that are more easily understood by our audience. And with that, I think I'm giving you an introduction of what sustainability is all about, why it makes sense, and Simon will take it from here.
Thank you, Gerald. And you started to mention some numbers, and we'll dig into numbers for sure in this second part of the presentation, which is more focused on the foundation support part. And I wanted to bounce back on this diagram that you presented, Gerald, which is showing the strategy like the avoid, reduce, substitute, and compensate, whether it should be in an order where you cannot avoid and reduce. If you cannot reduce, then substitute. If you cannot substitute, then really go compensate. That's really the last resort that you have. But the approach is we don't want to be at compensate first. We want to just go step by step. And the approach that I wanted to share with you today is take different point of views from different stakeholders on a construction project and see what it means in practice. So if you look at as an owner and then avoid, obviously, avoid construction is do not build, which is not always possible. If you want to reduce it, you should see it as more build only what is necessary. Substitutes is you may want at some point revisit some architectural choices if you have the ability to, because some panels, some kind of specific materials that you choose may not be the less, there could be some less carbon intensive options. If you cannot, then compensate. Plant trees, this is more of a side note than a real action. This is something that we want obviously to avoid as much as possible and go with the further options. As a consultant or as an engineer, avoid. What can we avoid except loads? No load is obviously the best approach. If we cannot, then let's lower the design load. Sometimes we see that some loads are maybe a bit like, because the project is very early or because there are a lot of unknowns, maybe we should sometimes take the time and then go into more in-depth and then try to lower these values, because after that will have a consequence on all the other trays that are involved in the project. Substitute is about specifying maybe to have lower carbon intensive alternates used on the project, because there is this possibility at that level of involvement on the project to provide some clear specification on substitution. Plant trees obviously as more of a running topic than anything else. If you're facing challenging soils, then try to avoid them. It might be, of course, we cannot change the location where the site is going. But if you can avoid them, the challenging soil, then obviously it means you go for shallow foundations, which is the best option what you want to target. If you want to reduce challenging soils, what does it mean? You need to improve them. That's what we call ground improvement. If you cannot reduce this challenging soil, then you have to substitute them. And substitute them would be with options that are, then you have to replace this soil, which is a dig and replace option, or you have to substitute with concrete, and you don't take into a design, and that would be deep foundations. Obviously, you don't want to plant trees even if you are challenging soils. So the approach here is to say, well, if you cannot, the way we wanted to see is go up and down or top and down, but just start with the whatever you can, and whenever there is a possibility to go up in this ladder, just go for it. And then you would have a more sustainable project. And this is what we call at Menard, the less is more Menard. So that's what we wanted to elaborate on, and then say, well, if we go for more value engineering, then there would be less ton CO2 equivalent. And how do we measure that on a ground improvement project? Bill mentioned the EFFC DFI carbon calculator, which is a great tool that we've been using for the last couple of years, and then we keep using to compute absolute values of ton CO2 equivalent, which is the metric that is showing what is your carbon footprint, or what is your embodied carbon, as we call it sometimes, of your project. So it is split in 7 different categories, which are very clear as a contractor point of view, but maybe less clear as a consultant or as an engineer point of view. You have material, you have freight, energy, mob demob of your equipment, people, transportation, and assets, and waste. So on a classic project, what does it mean? Energy and assets are obviously the main machine. So this is a construction project with control modules columns. And clearly you can see that any ancillary equipment, the main equipment, the pump, for instance, are definitely the energy and the assets. People transportation is our crew. There is nothing we could do with our crews, and we are not there yet to go without them. Let's not reduce them. The third aspect, obviously, is on the freight. It's what we have to move on site. Then there is everything about the material, which is the concrete and the rebars in that specific case. And then there is the waste. So once we have these quantities, that is part of our quality control daily procedure, then we have to rely on local emission factors. And when I say local, this is key. Emission factors can be what you multiply, what Gerald showed is what you multiply your quantity to get your ton CO2 equivalent. If we are using emission factors that are too countrywide or not specific to your area, obviously what you measure is not, it's not relevant enough to your local component. So that's why this example from Concrete BC for BC project, where provincial, every province in Canada has Ready Mix Association published baseline that are able for a given concrete mix, let's say 20 MPa concrete, are giving a baseline of a global warming potential, GWP, which is the row we are talking about. So concrete suppliers, for instance, are are working on their mixes to be able to lower these numbers, but they also, these baseline that are publicly available are a good indicator of where you stand at when you order such mixes. The best also is to rely on environmental product declarations, or EPDs, that these suppliers can provide and that are very specific to your project. And these numbers can be input in your carbon calculator, which makes your total value of total embodied carbon as precise as possible. So we did the exercise on 110 projects that were from ground improvement project that took place in Canada between 2020 and 2022. And this is, and we were showing what we got as a result. So more value engineering, less CO2, but less than what? And the key question is the baseline. So we took among these 100 projects that we looked at, let's take one example of an industrial project that took place in Ontario. It's a warehouse building. It used to be a gravel pit. There are 3 to 5 meters of fill and poor soils. And then on top of that, the owner wanted to have a grade raise. So the initial solution was to go for dig and replace option. What we suggested was to go for dynamic compaction option, which you may have heard of, or otherwise you can refer to the previous webinars recording to go through that. The dynamic compaction option basically allowed the client to upfill with borrowed material, and we compacted the existing and the new fill at the same time to be able to reach a 200 kPa SLS bearing capacity. So in terms of carbon, what's the impact? And we can talk about the financial impact as well. The dig and replace option had a total embodied carbon of around 1,800 tons CO2 equivalent when you add all the different categories on the DFI tool, as we mentioned. If we look at the dynamic compaction alternate, and in taking everything into account, the people, transport, all the categories that we mentioned, we were close to 1/8 of the final value. And this is one given project. So how can we generalize that information? Because we are, as a contractor, Menard obviously has all the information about the different categories that are provided in the carbon calculator. And there is this great webinar that I encourage you to go through that took place last month with the DFI. That is mostly like how to use a carbon calculator for consultants. So we did this exercise and we thought, how can we generalize or at least have an option to assess the embodied carbon of a ground improvement technique and really go for absolute values, because this is what we want to target. We know that the embodied carbon is a function of the depth of treatment and the soil conditions, which you usually know. It's a function of the ground improvement technique that you will use for sure, but it's also a function of the out-of-surface structure. So, and that's something that obviously makes it hard to compare from one project to the other. So we looked at all these 100 projects and we try to go for, and we try to provide some trends. Our approach was to look at the total embodied carbon that we got for this different like depth of treatment and then type of techniques, and then divide it by the square meters of gross floor area, which is total area of your building. So if you have a residential building with multiple stories, you would multiply all the number of stories by the area of each story. If you have an industrial building that is one story, it would be almost your building footprint. And the numbers that we take, and this is a chart that we have in an article that we presented last week, actually at the CGS conference in Saskatoon. And we show that as early as you can be in the project, if you kind of have an idea of what type of technique, so control modulus column, which is concrete-based, dynamic compaction, RAC, rapid impact compaction, vertical drain, or stone columns with different like depth treatment, depth buckets, then you're able at least to have an idea of your carbon budget of the ground improvement technique. So obviously the range is not significant because we are looking at 100 projects. We wanted to provide these numbers for the consulting team to be able to have a first idea of the carbon budget of a ground improvement solution and compare that with another alternative that would be possible for that project and go for the less carbon intensive option. It's interesting to notice that, for instance, if you look for a concrete-based method for concrete modulus column at 15 or plus meter of treatment, then you have an approximate of 30 kilograms CO2 equivalent per square meters. But if you look at the equivalent with an aggregate-based solution, which is stone columns, which is the column here, the SC column, for the equivalent depth of treatment, then you can get higher values of kilogram CO2 equivalent per square meter. And this is our baseline, and this comes from the distance of the quarry and the multiple trucks that have to come. So we thought that having a kind of a well-spread techniques and different treatment, this graph shows something, and it's our baseline for us to reduce even more. How can we do better than that baseline? Because that was the last 2 years. And if we come back to this grid here, and as a ground improvement contractor, what can we do? With the range of technique that we have, how can we avoid? Then let's not use material, like Gerald was saying. If there is a possibility to go for a technique that doesn't have any additional material, let's go for it, because obviously the carbon impact will be lower. That's the example that we saw. Can we reduce our scope? Can we, obviously we can, if we can optimize our design, if we get more testing, if we take the time to optimize and reduce that value. Can we substitute? That's our third option. If once we look at all the options available, when we optimize our design, then we can go for recycled aggregates, we can go for low carbon concrete. And this is where the relationship with our suppliers is key to be able to lower again our impact. And we would not plant trees. So this graph is similar to the one that Gerald presented in the carbon calculator. It is based on our 100 projects. And when we look at the different techniques, obviously what we want to do is focus on the main sources of the embodied carbon for different techniques. For control modulus columns, we will look at specifically on the materials, right? It's the graph on the right-hand side. For dynamic compaction, obviously, it's about the fuel. Have more fuel-efficient machines on site or working on the idling time, et cetera, et cetera. We wanted to show you a practical example of a project. It's a residential project this time. It's a 5-story residential building. There is an underground parking. Nothing too specific. It used to be to sit on a former landfill, and we had 15 to 20 very soft clay conditions here. The solution here was to go for concrete modulus columns, which was a cost-effective solution for the client, but also we wanted to push the exercise a bit beyond our classic exercise and go and evaluate our baseline there and see how we can apply the avoid, reduce, substitute logic to that specific project. So this is a real project that took place, right? So we are talking about the footing support here. And our baseline for the footing support was 900 ton CO2 equivalent. Our second step was to go with the client, the discussion with the development team, go from optimization, do more load tests, and we were able to reduce by around 5% our carbon footprint for the same scope. Then we talked to our suppliers and went see if there were options for lower carbon options. That's the substitute approach. And that again, so the 45 comes back to the 900. And so from 900 ton, we were able to go down to this 485 ton CO2 equivalent. And that's the same approach at what Gerald showed for this subway station in Toronto, where there was this exact same approach that as a contractor you can go through, or as a consultant, make sure that your contractor is going through the same steps. So in the end, in fact, more value engineering is definitely less ton CO2 equivalent. It's also less dollar, and this is something like it's also less time, and it's also faster. And as Gerald likes to say it, and we prepare that webinar, it simply makes sense as is, right? So let's conclude on what we've seen. So starting very wide approach with sustainability, then diving a bit more into construction, into foundation support, and now into like ground improvement or sustainability, basically carbon footprint of foundation support. The avoid, reduce, substitute strategy, I avoid the compensate here, is key if we want to work towards more sustainable construction projects. This is something that we as owners, as consultants, as architects, as contractor, we should keep in mind wherever and whatever project we start to. The EFFC DFI carbon calculator is really helpful in our field, which is the geotechnical, for any geotechnical works, that would be helpful to get absolute values of total embodied carbon. If you run the analysis on extended, we did this exercise on 100+ projects, and we were able to provide orders of magnitude of absolute embodied carbon for ground improvement. We publish these values because we want to be challenged on these values. We want these values to be used as assessment as early as the project, and you can be in the development cycle, to be able to have an idea of what's the embodied carbon budget for the foundation support. Because this is where we're going. This is where the legislation and where the a lot of cities are going to, actually, at the moment. But this is not enough, and that's why, as Menard and this kind of less is more approach, we are challenging ourselves on a day-to-day basis to go beyond these values, which are our baseline, and be able to offer always the most sustainable foundation support option. Sometimes it is not ground improvement, and we are happy to provide that advice to our clients. And sometimes it is not even, we have to go with a substitute, you have to go for deeper foundations. But whenever there is an option to go for lower foundation, that's where, with the tool that we talked about, that's where we believe we have an impact on all this topic. Thank you very much, everyone. I think we are on time, and then we'll be ready to take your questions. So don't hesitate to share any question that you might have.
Before we do that, Simon, let me jump in and try to give the audience 2 more items as food for thought.
Sure.
First of all, when you walk around, you walk on soil. That is the normal foundation that we utilize. And when we're talking about foundation reuse, it doesn't mean that the foundation that you have is always perfectly adequate. Now, sometimes you need to do some improvement with that. But that's something where we really need to start thinking about when we talk about foundations is, why do you take, what is this, the basic foundation that's already there, the soil that is already there, why do you replace it entirely with a piece of concrete or a piece of steel? Why not start thinking about doing ground improvements, thereby reusing the foundation that you already have, and thereby come up with a more sustainable a more effective, a more efficient, a more cost-effective solution. That's number one. The second thing that I want to talk about briefly is this issue about the reducing of your foundation. We all know that when you are putting a structure subsurface, that you have to deal with site variability. Soils vary on a job site from one location to another. And if you do a very limited site investigation, then invariably you don't have a good idea what this site variability is, and you are ending up with all kinds of cost overruns or claims later on. What I find intriguing is that there's never enough money to do more elaborate soil investigations up front. People say that's not necessary, but there's always money, even much more money than what would be required for more extensive site investigation to address the claims and the cost overruns. If we were to go to a more extensive site investigation up front, which would allow us to minimize the risks, which is beneficial to the project cost, which would allow us to get a much better idea of what is really required, and also allows us to increase the resistance factor, we get a much more cost-effective design. So again, lower cost, and we get a more sustainable approach. And that's what Simon finished off with. It simply makes sense. When you look at the overall picture and when you combine everything, doing something sustainable is not something new. It simply makes sense because it's also more economical. It also has a shorter project schedule. And it kind of reminds me, and it shows me my age, when we in the 1980s started talking about quality improvement programs. People initially said, oh, that's only going to add cost. But in the end, it makes perfect sense that you do things right the first time, because if you do it right the first time, you don't have to repeat it, increasing your cost. Same thing with sustainability. If we come up with a more sustainable approach, it's more cost effective, it's a shorter schedule, it simply makes sense. Okay, Simon, let's talk about the questions.
Yeah, perfect. So on that cost aspect, actually, we have a question regarding if there is a price difference between classic concrete and low carbon concrete, which is a fair question. And what we see, I mean, in the trend that we've been seeing in the past few years when we started to discuss and partner and challenge, I would say, Avon suppliers, is they can be a premium, but you can also, as Menard, for instance, we are working with them to be able to go for mixes that would be also in the same approach, where we would have, in the end, it would be lower carbon and also more cost effective. So this is something definitely we're working about, and we should challenge our suppliers. There is a question about, maybe more for you, Gerald, if you know more about this Toronto LRT station that you mentioned. This is not ground improvement. The question is about, could you elaborate more on how performance-based design work was done for this project? This project Katie mentioned.
I honestly don't know. I took this example from Katie Costello for Isherwood, but I will get in touch with her and then get the answer to Tom.
Yep, yeah, we should be able to, or also refer to the that webinar that took place last September, where she presents. I think it's about the shoring. That's where the optimization was done.
Yes.
We have another question on, did you evaluate, so we talked about embodied carbon per square meter of gross floor area, and then did you compare the ground improvement technique with a traditional foundation? So traditional foundation, I would assume, wouldn't be shallow foundation, would be a deep foundation option or dig and replace. So we are, that's the reason why we publish this number, right? We do, as Menard, we do ground improvement, only do ground improvement. So that's what we can design, we can optimize. We are more than ready to be able to compare these values. We know we did on several projects, and we know that there is a percentage of decrease, but we would like to have also the same approach where we can compare these values to hold consultants when they are starting a project to be able to an idea of the different options that they have, given the soil that they have and the structure that then build on top of it.
To add to that, Simon, there is a case study, again, included in the DFI magazine that you can find online as well. In there, we have a Foundations for a Sustainable Future column. Every month, we emphasize or highlight a project or an approach. And one of the first ones was actually done by Keller, where they looked at a project in Singapore, where initially for an extension of a chemical plant, they were thinking about putting a concrete deep foundation in place. In the end, went with a soil improvement and get quite a bit of savings, both on cost, but also on sustainable elements. And I think this is where the carbon we have illustrated in the various webinars in the carbon calculator, very easily put the two options side by side. Enter the data in the carbon calculator and see then what your results are.
Yeah, okay. We have a question that will be for you, Gerard, regarding the UN Sustainable Development Goals, the SDGs. So we have you see a question? Here it is. We came to know from the webinar that concrete, steel, and aluminum contribute to about 25% on the carbon emissions. How is the UN Sustainable Development Goal is on this? Is there any goals or any?
No, this is the SDGs don't necessarily talk about dealing with a particular material. They're talking about making better use of materials in general, but it's not geared towards a specific material. But then when you start looking into the various sustainable development goals, obviously it has an impact on what materials you're using. And what may be useful in that regard is, again, a joint effort between EFFC and DFI, where we're putting guides together to help contractors, but also consultants, to address these sustainable development goals, how you can implement them in your day-to-day work. But it all comes back to a very basic understanding. In our industry, and when it comes to foundations, we only use a very limited number of materials. And whether it's concrete or steel or aluminum, the answer is very simple. Less is better. And if we can optimize our design, then we can reduce our emissions and therefore do something about Sustainable Development Goal number 13, which is the climate action. If we can also think about reusing those materials later. If you have a sheet pile in the ground, remove it again and try to use it again somewhere else, because then the emissions have already been completely allocated to the initial project and will no longer be allocated to the next project because you're reusing your material. And that is with the circular economy, that's another aspect that is addressed in the Sustainable Development Goals without specifically talking about concrete, steel, or aluminum, but just about materials in general. As a consultant, start thinking about using less paper in your office. That is not necessarily there's no Sustainable Development Goal dealing specifically with paper, but again, it's this avoid using this part of the pyramid. So the Sustainable Development Goals are formulated much more general, but those materials definitely have a major impact on quite a few of them.
Thank you, John. We have a question on if we, as Menard, are providing sustainable options and value engineering options while working with owners at the initial stages of the project, and how this initiative is working in Canadian market. So, yeah, as a design and build ground improvement contractor, this is our daily job, right? Whenever we are we start looking at a project and we have this first conversation with owners or whoever approach us on this project, we would for sure provide value engineering and then try to challenge the statu quo and go for a lower and more sustainable and more cost-effective option. And this is working very well in the Canadian market for sure.
Let me add one other aspect to this whole thing.
Yeah.
As owners, we have a tendency to do the design, specify exactly what we want, and then go out to a contractor and say, now go build. If you, as an owner, would take a step back, trust the contractor that you have to come up with a good design, and you only provide functional requirements, this is the amount of square footage that I need, this is what I'm going to do there, and come up with a functional specification rather than a very specific, this is what I want and this is how you should make it. Then you allow a contractor like Menard or many other design build contractors to apply value engineering. And when you apply value engineering, they generally reduce the cost substantially, come up with a more sustainable solution. So that is something that as owners, we really need to start thinking about. And as consultants, we need to promote to the owners that a functional specification, just as I gave you that example in Toronto, really makes sense and saves money and is more sustainable.
There is another great question on why, I mean, it doesn't seem very clear that CMC, so control modulus columns, have a lower carbon footprint to some column. I like that question. I mean, we can be surprised with the result that we get. And again, this is project specific, but what we can see is the concrete that you pour, usually the batching plant is closer to the, yes, concrete has a big impact. Batching plant is close. Usually for an equivalent storm column project and a CMC project or concrete-based project, you would have also lower quantities in the end. And then storm columns would have a quarry that is usually far from the project and a lot of trucks running back and forth, which accounts on the total carbon emission of the project. Of course, there are cases where storm columns will be more sustainable. But what we found in our study, and you can see that from the ranges, and there is no, that exactly what these numbers that we got, this is what we found.
But again, Simon, something else that plays a role there is what I showed in that slide. Try something new. Quite often as engineers and as consultants, we have a preconceived notion of what is the optimum solution. And if we think outside the box, if we start looking at different approaches and run it through the carbon calculator, you may come up with surprising results. And that is what this try something new is really all about. And what the example that Simon gave as well is that, yeah, at first sight, maybe it doesn't appear to be the most logical solution, but in the end it is. And if we are open to these new solutions, if we are willing to try something else, only then will we find out.
Yeah. We have an interesting question, and I think that would be, yeah. Can we monetize a ton of CO2, and has this exercise been done? And I think that's a great, and I think that's where we are kind of going as well. There is a price for a ton of CO2, right, Gerard? And I think it depends on every country. But if you want to run the exercise and you have the same, because it's hard to compare carbon versus cost sometimes, if you want to put everything into dollars, then that would be definitely a good approach to look at a project as a whole. Right, John? What do you think?
In various European countries, there's already a market where you basically know if you can reduce the emissions, what kind of monetary value there is. In North America, we're not that far yet, especially in the United States. We're still a long way off, but we're moving in that direction. But at the same time, though, you also need to think about what owners you're talking about. If you are talking to companies like Google that are saying that if you come up with a more sustainable solution, you are allowed to have a slightly higher project cost. At least it's incentive or gives the designers and the contractors an incentive to start working on it. But lo and behold, most of the time, the solution that you come up with is already more cost effective anyhow. But in Europe, yes, there is a specific price per ton of CO2. There's a marketplace for that. Here in North America, we're not that far yet.
Another question here on a fan, Gerald, that likes the simply make sense sentence. Do you think it is easy to convince clients with the use of ground improvement technique? Would you recommend any monitoring using these ground improvement techniques? So easy to convince clients. I mean, usually when you come, not all projects, right, are applicable with ground improvement. This is something we should keep in mind. But whenever it is applicable, it's usually the fact that it's more cost effective. And also now we see more and more the sustainability aspect coming into play for owners. This is something that definitely is taken into account, and convincing is, as a design and build contractor, we basically obviously stamp everything we do and then provide a bearing capacity. So the convincing usually works pretty well. On additional monitoring, this is something that extensive monitoring was done at the very early stage of these ground improvement techniques. It depends on the type of monitoring you are referring to, but if it is something that can convince, this is something that you could go for. But usually, I mean, everything has been done in the past to prove that it works, and there is some kind of testing that is being done on site, anyways, to make sure that our design parameters match with the ones that when we are on site.
And also monitoring, you can take that in a broader sense as well. As I told you earlier, a site has variability. Soil conditions are not the same everywhere. When you do ground improvements, if you apply a standard design of the ground improvement, say with dynamic compaction, that is standard everywhere, then you're basically going to waste money. So if you do cone penetration testing of that site beforehand to get a good idea of what the bearing capacities are throughout that site, and then utilize that CPT method as well during the ground improvement, that you can basically stop with your ground improvement when you've reached the desired levels, and you have a much more optimum solution and again a more sustainable solution. Because even with dynamic compaction, if you just lift that block of concrete and let it drop again, that takes fuel, it takes electricity, and if we can avoid having to go through a number of extra rounds, that just makes it only more sustainable.
Great. I think I'll take the last one because we are running out of time and we don't want to keep you from going to lunch. Can you share the carbon calculator? It's an easy one. Yes, we'll share. You should have the link in the chat. Otherwise, we'll send you the link to be able to download it. For the other question that we couldn't answer, there are still a couple. We will come back to you by email if you have your, if you left your name. If you want us to reply specifically and you send it anonymously, don't hesitate to use the chat to ask the question again. So thank you again to everyone for attending this session, and thank you again, Gerald, for being with us today to have your point of view on the topic. These webinars run on a regular basis. That's the 5th, as we said, and there will be a couple more this winter that are scheduled, and we'll be talking about industrial buildings. And so specifically in English, and then there will be a French version for our colleagues from Quebec. If you would like to go a bit beyond these topics on the sustainability and drive, we started very wide, as you can see, because that's the first of this webinar. If you want to go deeper and then have more understanding on some topics, do not hesitate in the survey to suggest some new topics for the following webinars, and then we'll accommodate as much as we can. Thank you again, everyone. I think we are right on time, and enjoy the rest of your day. And yeah, and let's make all these construction projects as sustainable as we can.
Thanks, Simon.
All right. Thank you. Bye, everyone.